Hello, in this video I will discuss the zero, constant and systems folder in OpenFoam tutorials. So I'll start a terminal and here I am in Windows subsystem for Linux, and in order to explore the file system I will run this command explorer.exe space and dot, and here you can see different folders. I saved the tutorials in this folder, and I will go to incompressible simple form and let's say Pitch Delhi. So here there is zero, constant and system folder, and before running simulation you have to change the name of zero folder to zero. And inside the zero folder you can see first file is epsilon. Epsilon is turbulence dissipation rate, and before starting simulation you have to define this. So epsilon is turbulence dissipation rate. Next, K is turbulence kinetic energy. Nu T is turbulent viscosity. And this nu tilde is related to some parameter related to SA turbulence model, and omega is turbulence dissipation rate, and this is related to K omega turbulence model. Then P and U. P is for pressure and U for velocity. Then the constant folder. In constant there is transport properties, that is here you can define nu, the viscosity, and that is 1e minus 5. Next, turbulence properties. And here you can see this is Reynolds average Navier-Stokes. The in short form it is written RAS. And there are number of turbulence models are available, and you have to set different turbulence model. In the zero folder you have to carefully choose the parameters, and here it is taken as K epsilon turbulence model, and there are also different version like K epsilon, K omega SST, and few other version of the different turbulence model. And here you can see turbulence is on, means we are going to solve the fluid flow system using turbulence models. And the next is systems folder. In the systems folder there is block mesh dict, and by this you can define the mesh. Next is control dict. Here you have to define which solver you are going to use. Like here I am using SimpleFoam, so you have to write SimpleFoam, and if you are using PimpleFoam, PigeoFoam, like that, you have to change it. And start from, that is the start time, and the stop at, that is the end time, and delta t, what is the time step size you are interested to take in your simulation. And based on your simulation you have to change it by using the current number. You have to calculate the current number for your case, and write interval here after how many time steps you are interested in saving your case and data file, mainly the data file, after how many time step you are interested. Based on that you have to write the interval, and these are few other settings. Next, the schemes. Like whether you are interested in steady state or transient or unsteady simulation, then you have to define these. The DDT scheme, then the grad scheme, the divergence scheme. Likewise there are different schemes, so you have to carefully define all these settings. Then similarly these are the solver parameters, like for SimpleFoam and the relaxation factor. And this streamline is mainly for post processing. So that's all, and here I discussed everything about zero, constant, and system folder. And in constant folder you can see there is no mesh, and when you will run block mesh, then only the mesh file will be generated. So I'll enter into that folder from the terminal, and I'll run block mesh. Here you can see the mesh is generated. Yes, here you can see the mesh is generated, and if you want to run the simulation, then you can simply run SimpleFoam. You can see the simulation is started. So in this video I discussed the zero, constant, and system folder, and how to generate the mesh, and how to run the OpenFoam simulation. Thank you.